Chemical equilibrium. We require 0.1 molar ferric chloride solution, 0.1 molar potassium thiocyanate solution, 0.1 molar potassium chloride solution, distilled water, 4 test tubes labelled A, B, C and D, test tube rack, a clean 250 ml beaker and measuring cylinders. Take 10 ml of 0.1 molar ferric chloride solution in a measuring cylinder. Pour it into the 250 ml beaker. Take 10 ml of 0.1 molar potassium thiocyanate solution in another measuring cylinder. Pour it into the beaker containing ferric chloride solution. A deep red color is obtained due to the formation of ferric thiocyanate complex. Take 50 ml of distilled water in a measuring cylinder. Pour it into the beaker containing ferric thiocyanate complex to dilute the solution. Take 10 ml of the above solution in a measuring cylinder. Take the test tube labelled as A. Pour the solution into the test tube. Take another 10 ml solution in the measuring cylinder. Take the test tube labelled as B and pour the solution into it. Repeat the same process for the other 2 test tubes. Take 5 ml of distilled water in a measuring cylinder. Add it into the test tube A and shake the test tube well. The color of the solution in this test is taken as the reference color. Take 5 ml of ferric chloride solution in a measuring cylinder. Add it into the test tube B and shake the test tube well. The color of the solution deepens because the increase in concentration of Fe3+ ions results in more ferric thiocyanate complex and shifts the equilibrium in the forward direction. Take 5 ml of 0.1 molar potassium thiocyanate solution in the measuring cylinder. Add it to the test tube C and shake the test tube well. The color of the solution deepens because the increase in concentration of CNS- ions results in more ferric thiocyanate complex and shifts the equilibrium in the forward direction. Similarly, take 5 ml of 0.1 molar potassium chloride solution in another measuring cylinder. Add it to the test tube D and shake the test tube well. The color of the solution becomes lighter because the increase in concentration of K+ ions decreases the concentration of CNS- ions and thus decreases the concentration of the complex. Thus, the equilibrium shifts in the backward direction. Now compare the intensity of colors in test tubes B, C and D with the red color in test tube A taken as the reference color. Record the observations in a tabular column. The equilibrium between Fe3+ ions and CNS- ions is directly proportional to the concentration of the reactants.